Okay, we're live and online again. Welcome back to QGIS Open Day sessions. Right now we're being joined with Vincent Cloarec. How do I pronounce your name nicely with a French accent?
That's right.
And
Hello.
hi, Vincent. Thank you very much for taking the time to show us about mesh today. So I will just for those people who are going to be joining on the live stream, like to mention again that we might have disconnected around an hour. So if you find the stream stops, just don't go away. I'll just need a minute or two to get it restarted again, and then you can just stay watching the same feed, and it will restart. And for questions, if you have any questions, just please ask them in the chat, or if you ask them on, if you're in the Telegram room, you can ask there as well. Mainly I'll be watching the YouTube live chat, and then I will sort of save them up for Vincent when he's got a chance in his presentation to answer them. Anything else you want to add before we get started, Vincent?
Okay. I am here to present a bit the mesh layer in QGIS. Meshes are essentially vertices that are connected each other by elements. You have faces that form a 2D mesh, edges that form a 1D mesh, a network, stack faces. 3D stack faces are 2D mesh with several levels on top of each other. So on the picture on the right, you can see a typical 2D mesh with the faces, and the vertices is defined here in this faces. You see you have 1, 2, 3, 4, 5, 6 vertices. Here on the center you have a 1D mesh. I think this is I don't remember a drainage for rainfall. And on the left you have 3D stack mesh with in fact 2D mesh with several levels. Vertices are defined by position with X, Y, and eventually Z position. Elements are edges of faces, and they have indexes of their vertices. What is great with mesh layers, it is that the position and size of each mesh element are completely flexible. So in contrast of grid defined by raster layer, where you have a little square everywhere with the same size, with mesh layer you can have whatever the size of the mesh of the faces. Okay. Meshes can be associated with datasets that consist of value and vertices or elements. Here on the right, you have an example of data and vertices. So for each faces, you can have a color ramp that represents the data. The data on inside the faces are interpolated. Or you can have a vector defined on vertices. With data on face, you have all the value that is applied on the face, and a vector on the center of the face. In QGIS, there is a possibility to resampling the data to have a nicer look that will be the same as data on vertices. Okay. Dataset groups can have several datasets for different time steps. Meshes can be time dependent, and it's completely integrated to the new temporal framework on its time manager. So here you can see some arrow moving on the contour also. So a very quick presentation about the meshes, about the mesh layer. maybe what I want to do now is to present some use cases. But if anybody have question, or team, maybe you have question about mesh.
So far, there's no questions. So
okay. So let's move on. Okay, what I want to show you several things. Excuse me, I am in the street. Some
no
result
problem.
Okay, some result of hydrodynamics models. QGIS read the MDL libraries that support several format of meshes. There is a lot of format of hydrodynamics models. What I want to show you it's a result of two-flow models on full 2D models. Okay, here, can you see QGIS? QGIS?
No, I cannot. I can just see your presentation.
Okay.
Okay, yeah, we can see it now.
Okay, there is a little lag. So here, you have, I will do something. What I will do, it is, I will load from scratch a mesh layer. Okay.
I think your screen is frozen. Can you just move the mouse so I can see?
Can you see something?
I think it's frozen.
Oh.
So, do you have Chrome on your computer? Because maybe you should join with Chrome.
Look,
I'm sorry, Firefox.
I have Chrome. Okay, I join you in 2 minutes.
Okay, great. Well, Vincent's sorting out his Chrome. Maybe if anyone has any questions, you can feel free to put them in the background, in the chat.
Hi, Tim. I'm here. This is Saber. I'm as a
hi, Saber.
I can help.
Welcome.
Thank you.
You want to sing a song for the audience while we wait for?
No, I'm not good at singing. But, if there is any question, I'm happy to answer. And I think some exciting news on integration of point cloud PDAL. It will bring a whole opportunity to read in future generated mesh from point cloud, so that you can read that through MDAL. So there will be an overlap between MDAL and PDAL, because one of the products of the point cloud are the interpolated surfaces.
So will each return level be a mesh layer or something like that?
I'm not quite clear, Martin or Peter, Patrick, if they are around, they can explain.
Okay.
But the triangulation you create from the mesh you create from the point cloud, there are already some support for the basic one, but can extend it from that side. So I'll pass it to Vincent. Sorry, Vincent.
Amazing.
Hello again.
Hello, welcome back.
Okay. Sorry.
No, it's fine.
Let's go sharing my screen. Okay.
Okay, it's showing your screen now.
Okay. Can you see QGIS?
Yes.
Okay. So let's browse. I will start with a quite big mesh. So it may be quite long to load.
What is the big mesh in terms of how many megabytes or gigabytes or?
This depends of the format. This is a text format. So in terms of size, size on disk, it's quite big. On this one, let me what is important for QGIS once the layer is loaded is the number of vertices on meshes. Here, you have less 1,700,000 vertices, so quite big, but not so big. So now, here I have loaded only the team of the mesh that represents the terrain elevation. For this format of mesh, I have to load a data set. You see the side here. The base of the mesh, the frame, you have 100 megaoctet, and yeah, you see here the size of the data set. So now I load the data set. Okay, in this mesh we have quite a lot of data set. You see here the bed elevation, depth maximums. So you have quite. Okay, let's visualize it.
Vincent, could I just ask quickly? Could you just explain a little bit? So you added the mesh layer, and then what is the? Could you just explain the concept of the data sets, or how, are there two separate files that are connected to each other, or?
Yes, it is a model that produces the two files. One file for the frame. Not all the meshes are like this. So you have a file for the base of the mesh, the structure, the face, vertices, and you have other files for the dataset, group dataset. Dataset represent for hydraulic models. For example, you have your water depth, water elevation, the flow, the velocity of the flow, what you want. So first I have loaded the frame, the structure of the mesh, and then I have loaded the data set. For some format, you load all these data are on the same file. Okay? I don't know if I am clear.
Okay, thank you. Yeah, that's clear.
Okay.
So QGIS won't automatically see that the two files are sort of linked to each other. If you add the first, if you add the mesh, it doesn't automatically pick up the data set.
You load the mesh, you load the files, and no, you load only one files, and maybe you have only the meshes, so you have to load the data set later, or maybe you have all the data on the same file.
Right.
Okay. Let's go. So for rendering, layer steering. Look for here, you can see all the dataset available. You have possibility to visualize a scalar value. It is a little square you choose. What is nice to do? It is a vector velocity. And with the time controller, you can move. Yeah, here the mesh, the arrow are too coarse. What is good to do is to now if you zoom. I don't know if you can see the arrow.
Yes, we can see that.
Yes, you can make different color depending of the magnitude of the arrow. And see if I animate. Maybe it could be more, it could be speeder. I don't know if the connection is enough to see the.
Yeah, yes, I can see. We can see perfectly. Thank you.
Oh, okay. We can see other data sets. Water level with the velocity arrow. to represent the vector of data, you can use arrow, you can use streamlines. And you can use traces.
Oui. Ça va? Ah, c'est les clients qui me donnent ça. Maintenant, c'est comme ça. Ouais, je te dis ce matin. Tu vois ce midi-là? Ouais, ce midi. Lequel Express? Il y a le seul Express. Ouais.
Yeah, sorry for the noise.
That's okay. I hope people don't mind their conversation being broadcast to all of QGIS world.
Okay. Here you have some big traces that represent the flow, and the color represent I like when there was less value. I change, yes. Let's move the maximum. Now you can see a typical hazardous representation of a mesh layer with the scalar value on the vector value. With the big mesh, we can explore 3D. 3D. Let's go for 3D. Oh no, yes, because.
John, ouais, tu veux un petit poche, hey,
let's go. Yes, 3D view. 3D view. 3D view. Okay. So for 3D view, you have several possibilities. You can see the terrain, the elevation of the vertices that represent the dam. The picture will be more okay. Wow. Let's. For now, it's all green. Okay. Nicer now. I am on my laptop, so navigation is not very easy. Sometimes I will put set a vertical scale. Okay. Everything is okay. I want to rotate the view, but with my laptop, it's freezing. Oh yes, because it's a big mesh. Maybe it's long to reform the 3D view.
Okay.
During this time, I will take a real mouse. Maybe easier to.
Non, c'est clair aujourd'hui, en termes de beauté, c'est pas la
Let's try with this. Okay.
Moi, je cherche plus du côté de la maison pour le poser, ça va me plus beau, tu vois.
Yes. Okay. It's here now.
Non, juste grenadine. Hein? Tango, voilà. Et c'est la limonade. Yes. Et ça va.
Now you can see the 3D view. Can you see something here?
Yes.
Okay. We can smooth triangles.
I
prefer this view. now you can see well the bed of the river and all the terrain on the bank. I like to put some wireframe, but very thin. Okay, I don't know if the resolution allow to see the wireframe, but on my side I can see. No. So this is the terrain. So now we can add the data set. To add the data set, you have to set the mesh layer enable 3D renderer. Okay.
Everything we've been seeing but so far was just the mesh elevation rendered by the style from the 3D terrain base. Like it wasn't using your layer at all, the layer properties.
Yes, you the setting for the data set it is using the layer properties. Exactly. Okay, I have to put the same acceleration, vertical acceleration. And I hope soon we can see the water level. Yes, but green. No, with color. Wow, 3D view, sometime I can add the wireframe to the dataset too. But I will change the color because it's not the real color of water. Blue, it may be more realistic. So the elevation of the dataset are here defined by here the water level. We can define other dataset group, other value for the color. Let's use, why not the depth? Yes, here. But still blue, but with okay. Now you can see the full plan in the 3D view. All this is only the mesh layer. There is also the possibility to add the arrow on 3D view. Yes, we got it. Yeah, and now you can see the arrow and change the color of the arrow from yes, this is a single color. We have to choose here a single color. Why not red? No, I don't know if it is beautiful, but let's try. Yes, red color. That represents the arrow. We have the size depending of the magnitude of the velocity of the flow. Animation could work here too, but with 3D it's quite slow. And maybe my laptop will not support the streaming and the handle of the 3D view. No, maybe. Yes, but it is too slow. We will see later, nicer with less big mesh. Okay. Maybe you can just, I will start and load another project.
Ouais, ben, c'est un rythme qui est comparé avec quoi mais tu sais, c'est mort, les gens sont. Il n'y a pas de gens comme des gens. Tu peux les voiture.
Squeezing.
Sylvain is asking why not disable power saving mode to make it go faster. I don't know. Is that something to think about?
Okay. You can see something now?
Yes, yeah.
Okay. Let's have a little animation in the 2D view layer. This string. Arrow. Why is not working? Oh yes, because we have the start of the. Be patient. There will be more water on the plane.
Ouais, c'est le rôle du téléphone. Et répondre et appeler, quoi. Tu vas envoyer beaucoup de tout ça. Tout est l'histoire. Mais Steven a redémarré. Oui, mais je crois qu'on peut.
Ok. What I can show you now, it's another type of result from the Flu 2D, where we have a mix of 1D and the 2D layer.
Là, il a compris, parce que là, il a bien analysé avec l'imagination là, et puis on a comme si je ne dis bien
No, not here.
Ah ouais, merci de
Okay, now you have two types of mesh. Mesh 1D. This is the line you can see in yellow. I can. It's not very good like this. Yes, with animation. Can you see the animation?
Yeah, it looks beautiful.
That represents the flow on the river. Here, you can have a fixed size, a fixed width, or variable width. That will depend on the value of the data set. So here I am a variable size, and I can set the extreme value here. So if I want a thinner or a bigger, very big, maybe, yeah, very big. Okay, sorry for disturbing. No, I had the 2D mesh of the same model. I will just make this thinner because we could not see anymore the 2D mesh. No, not this one. Here you can see the square that represents the mesh, and the blue color, the dark blue color, represents the flow on the full plane. We can add flow arrow. And we move the contour to see only the arrow and move. These arrows are very little. No, they are very big. Let's set nicer size. Okay. Now you can see our presentation of the full plane with arrow on the full plane on the line of the 1D mesh. Then that could vary. Okay. If there is any question?
Just one from me.
Yes?
If you're doing a 3D fly-through on the mesh,
Okay,
and you're doing temporal animation, will it all work together?
Oh, yes. Let's try it.
And there's one from Werner. He wants to know which algorithm did the calculation, like flow 2D or Hydro S? I guess that's for preparing the mesh, right?
Sorry, I don't understand the question.
Werner Macho is asking
Yes.
if anyone, or do you know which algorithm was used to do the calculation to create the mesh, like flow or flow 2D or Hydro AS?
Yes. This is a model that produces all the data. That will depend on the software that produce the model. TwoFlow and Flow 2D are not free support, but there is several software like Cloarec or Cloarec that are free. Anuga is free too. Some other two, I don't remember all. I don't know if it was a question.
I'll wait for Ben to respond and come back to you. Yes.
I think here we have maybe a problem with this data because we don't have the value of the vertices. So maybe we could not render the dam. Let me thinking about why we could not. I don't remember. For some model, you do not have the Z value of the vertices. So you have to find another way to produce the dam. You could know with the master version of QGIS transform some value of the mesh on a raster layer, and then view the dam on 3D view. This is a workaround for now to display the dam of the mesh.
Is there a way to assign Z values to a mesh from a DEM? In other words, the other way around?
No, not for now. Wish list, but not for now.
Okay.
I am afraid that for this mesh, we could not render a good 3D view. Maybe we can look at some meteorological data. And with 2D, we can have some fun, some view with. Let's go. Okay. This is the Lesser Antilles, where I am living. And during September, 2017, we have a big hurricane, Maria. No, I am here. So this is the representation of the hurricane with a mesh layer. This is a GUI format that you can download on the internet. You can see the trace that represents the speed of the wind, and the gray color represents the rainfall value.
Are there any analytical tools for this to work with mesh? So, for example, that you can.
Oh yes. I am used to direct download the data from the internet, but there is a tool. It's a plugin. I think it is a download grid or something like that. Or you can download the latest grid produced by several meteorological organisms.
And can you use this data, like let's say you take a snapshot in time of that data? Can you export it to, or can you use it in a processing algorithm, for example, or do some kind of overlay analysis with it, with other data, vector data?
You mean? So sorry, I don't understand.
I mean, for example, if you want to extract polygons of the high rainfall area, or something like that.
With master now you can there is some process to export the faces, the vertices, and or value on grid to have some vector layers with value on of the mesh.
Tim, there is also, sorry, Vincent, there is also mesh calculator as well, because you can do like aggregate function over time as well, like getting the maximum of rainfall over the whole period after a hurricane, for example, in this case. Okay. You can do...
Yes, you have the mesh calculator, that's it. Here you have the mesh calculator that can, but here I have a problem, data set, I don't have the data. Ah yes, because I have to select the data. Okay. Here, mesh calculator. You can do some calculation with the dataset value. You can store the result. You can store the result on a file, or you can store only the formula in the QGIS project, and so the calculation is done on the fly. Maybe if you want a stronger wind, we can multiply it by 10, for example. No. Invalid group name, yes, big wind. Okay, let's go. No. Here you have big wind. So you can use this dataset group to analyze or to visualize. If we can do. Yes, yeah. But it's only scalar value are supported for this tool. So now you see the scalar value on the back that represents the big wind.
And can you do things like use the selection tool to select 5 faces and, I don't know, export it to a different data set? Or
no, selection tools don't work, but identification tools work. Yeah, you have the value here. I click on my place, and I have the value when I clicked. Oh, I said we can GRIB dataset are not native 3D dataset, but if we want, for fun, we can see it. I will stop. Yes, okay. You can see the result is in 3D. And if I want to see my my layer, I will close this. Layer steering 3D, enable 3D. I will just, oh yes, I have to. No, for now, yeah, there is nothing to see because I have to make an exaggeration too strong. Yes. Yeah. Okay. Little smoothing, little wireframe. Okay. Smoothing, a bit of color. I am using on live. Huh? Okay, let's go. Oh, yes, a little flickering, but you can see just for fun. Here you can see the wind on the height of the cyclone, of the hurricane.
Why does it only show to that small box area? Or
oh yes, it's I have choose only this part because if the mesh is too big,
it's too slow.
Yes, that's
okay.
it.
That's amazing.
Okay, this is freezing now. Yes. Maybe I crash QGIS. No more reaction. Okay. Let's restart the session. Voilà. Okay. We have seen some meteorological data. What I can show you now, it is another way to use meshes. It is use meshes for triangulated irregular network. It's another way to represent a terrain elevation. For now, we had raster layer to represent them, but mesh layer can be used to represent them. I will try to show you how to make a mesh them live with the 3.16 version. You know, have thin mesh creation. So with the vector layer, you can make a thin mesh. As you can, you could make a raster them with this tool. Now you can also make a thin mesh with this tool. The background is the same for the two ones. It is a Delaunay triangulation. So let's try with some data. What kind of data can yes. Let's do it for this is quite big. Oh no, not this one. Sorry. This one is quite small. Run the layer. Okay. The motorcycle. No, it's not this one. It is this one, I think. It's not a raster. It is a vector layer, but with a lot of vertices. I take the tool. Here you can see the vector layer. You choose the value on vertices to have the Z value. You add it. You choose the format of the mesh. I prefer here UV because it is a binary file, and I will not save for now the mesh. Okay, let's go. Adding vertices to the configuration, creating mesh from configuration, and saving mesh to file. Okay, we got it. So now I will remove my vector layer. Now I have the mesh, and we can see it in 3D view. Little exaggeration. Okay. Change. Okay. I got an issue. Oh yes, I don't choose my mesh. Okay, got it. Maybe a nicer color ramp. I prefer discrete. Okay, let's go. I think it's the wireframe I see because it is too thick. So I have to change it, make it a little bit thinner and smooth triangles. Okay, let's go. Now you have all them in 3D view.
Wow.
We can play with light. For now, we can apply the map, the 2D map on this, but it is on my wish list. We can only see a unique color, single color, or color ramp shader. We can have a big exaggeration to see more of the details. Okay. What is interesting with Mesh Layer 14? I will make you a little demo of the flexible particularity of the mesh layer. Okay. I make a fake tin from a very simple vector layer. You can see here some lines. These lines have Z value. No. Z value for each line. Z value for, sorry. My French come back. So the tin from this vectors layer are here. I will remove. You can see it in 3D view. It's a very, very simple mesh layer. You can see the little dome here. Yeah, very, very, very simple mesh layer. Okay. So this mesh, you can see the scale bar. This mesh size is 20 kilometers. But if you zoom, the resolution will be always quite. And if you have little details like this, resolution will be, you can see here you have 10 meters, but if I zoom, 1 meters. Now we have centimeters, but we can continue. Now we have 2 millimeters. We can continue. We are under the millimeters. So the precision of the data do not depending of the zoom. We can have a very big precision, whatever the scale. This is quite precious when you work with wire or rod, because for this linear structure, you need a big extent and a precision very little. I don't know if I am clear.
So you're saying basically you can store. Mesh is a good format for storing data at different scales within the same file.
Yes. On the size of the file is a very it's not very big. No, not some. This file is less than 1 megabyte. 1 megabyte sorry. Okay. What I can show you. If there is any question.
We do have a question from Sylvain Poulin. I hope I said your name right, Sylvain. Could we create a 3D temporal mesh as well? So I think you've shown already, but maybe you could just
3D. Yes.
3D temporal. So
yes. Yeah. Let's do it. Why can I show? Abandonné. This will not change. This will not work. Remove. I don't know if I have. I think this project is wrong. Yes, this project is wrong. Maybe this one. Okay, let's move it.
Wow.
I don't know if this picture answers the question. Let's
see. Let's wait for Sylvain to reply in the chat.
Sometimes pictures are easier to answer than speaking, especially for me. There is a bit flickering.
I have a question as well. If you wanted to edit a mesh by hand, are there like digitizing tools for making meshes, or is it only ever practical to have a mesh made from another data set?
Sorry?
My question is, in terms of creating mesh data, so you've shown us workflows, you create a mesh from, for example, a vector data set, or you get it from the internet or something, but are there tools for hand creating mesh data sets in the same way we can digitize a vector layer? Is one able to digitize a mesh? So, is there practical use for even
No,
wanting
not
to do
for
that?
now. No, the only way for now it is to use a team mesh creation to have a mesh for now. But then maybe in the future we could. You can easily do a mesh by hand, vertices by vertices. You need some regularities to make the mesh. So maybe one day you could, but I think the next step is to make algorithm to create other type of mesh from data. Maybe yes, it's I have worked on project based on QGIS, but you can put point vertices per vertices to create a mesh. But for now, it's not ready. Maybe in the future, step by step.
Mm-hmm. So Savant says thank you. He also wants to know in processing. Can you create temporal mesh using processing tools?
You can create other dataset with the mesh calculator from other dataset. But that's all for now for temporal dataset. Maybe soon. We will see.
And a couple more questions from me. Do you have an attribute table view for a mesh? Like, can you pull up like in a vector data set, we can pull up the attribute table and see all the properties. Is there a way to view the mesh as a table?
I think the only way is to use the identification tools, or you can use also Crayfish, the plugin Crayfish, to make some plot on the mesh. We don't have do that. Let's do that a bit. Let's me. Okay. Yes. We can use that. I choose the mesh. I choose the way to render. I choose format. A bit slow now. I will stop. Yes, my computer have some difficulties. Yes, okay. Here you can see the value on the mesh. Oh, it's freezing a bit. Okay, stop. And now, if I am waiting. Sorry, it will take several seconds. Okay.
Okay, we're back online, I think. I'm just checking with everybody in the room.
Oh, the people have to come back.
No, but they need to wait for the stream to reconnect.
Okay.
Okay, yeah, we're back online again, so you can continue.
Okay.
Thank you.
I'll restart the capture. Yes, okay. Now here you can see the value of the mesh. On the we don't see very well. I will remove this. Yes, you can see the line here. So the value on this graph is the value on this line. Maybe we can. Oh no, we don't have the eyes of the eye of the hurricane. Let me restart. Yes, we can see it a bit, but not. Yeah, here you can see the height of the hurricane. You can change the data set. It's the pressure. The height here. Precipitation. No, there is an issue. Maybe the value has to be, or maybe there is nothing here for precipitation. Or maybe okay. So it is a way to see dataset value for meshes using the Cloarec plugin. You can see value on 2D plot. Or yes, let's try another one. Here it's the mix between the 1D mesh and the 2D mesh. So the line it is a 1D mesh. With Cloarec, I can make a plot. Time series, no, longitudinal deny profile. Okay, no, select profile from map. Okay, I don't know if you can see the part of the line I have selected. And now you can see the data with the evaluation.
Fantastic.
Maybe I can make, I'm not sure if I can make a 2D plot at the same time. Oh, yes. Let's do it. Mesh 2D, cross section, time, current time, group, depth, from map. Okay, let's do it. From map, okay. Here you can see the water depth on this line on the same time, depending on time. But there is no table on mesh layer. Often we have a lot of vertices or faces, so maybe it's not very pertinent to have this table.
Is there any way to link, like, create joins between meshes and other data structures? So, for example,
no. Maybe one day with location, but for now, no. Okay. What can we do now? Maybe I can show you a process to export data, but I have to start the master.
okay. With which kind of data did you say?
Vector layer. You can export mesh layer to vector layer.
Ah, okay.
Okay, let's go. I hope this will. Yes, okay, this is ready. Be patient. Nothing? The compilation is too long. I think it start soon.
You must just put -J99 in the compiler flags. That's a nerd joke.
Oh, it's long. Maybe I have to stop this, but I don't think so. Why this QGIS don't stop? Oh, yes. Where is it? Here, okay. What kind of data can we use? Let's start with this through 2D. Okay. Now you have all these tools that can be used to export data to vector layer. You can also make a raster from a raster layer, from a mesh layer. Sorry, you choose the layer here, and no, you can make a raster with 1D mesh layer. Dataset group select. You choose, for example, bed elevation. If you want a raster them. Sorry. Extent not set. We will have the. It is American dataset, so unit is fit. Output coordinate system optional. Let's try it with this. Maybe resolution was too. Yes. Maybe.
I think that's the sound of your computer running out of memory.
Oh, yes. I will stop it. No, before it crashed my computer. I will restart now. Okay. Let me start. Okay. Select bed elevation, extent. I think the raster area. Yes, I got it. No, you got the raster area from the mesh. The classical one. Oh, I don't see it. Classify. Okay. No, here you have the raster area from the mesh. You can do export the faces. Let's do it. Let's transform bounding box to target CRS. Okay, I have a CRS issue. Wow, I have an issue. Let's try with vertices. Oh, I got an issue. Maybe because it is master. I don't know. Let's try with the other dataset. I have an issue with master. And the last master. I don't know why. So maybe I could not show you. I will restart. Okay. Okay, we have the mesh. We have the square represents the faces. And let's try to export faces. Select. I don't have data set here. Okay, now I have the vector layer. I do not have choose data set, so I think the table is empty. Yes, table is empty.
Okay, I was going to ask. So if you choose a data set, it will write the attributes of the faces onto that.
Yes.
Okay.
No, I don't know why I couldn't choose the values. Oh yes, I know, because grid format has only value on vertices, so there is nothing to export. But if I use vertices, okay. Yes, I got it. Okay. I have the value here. You can choose also on grid. You define a grid. You can choose the time step too. Yes, you can choose the time step. But why? Yes, because I don't have temporal. Select all. Yes, now we have temporal dataset, so I can choose the time. So the current canvas time, define that time. You can choose that time here, or dataset group time step. Here you have all the dataset time step. You can choose one. And now if I export, of course, there is an issue because yes, with spacing, 10 meters. I have a very big big mesh because 10 meters produce very. Yes, okay. I have to stop QGIS. Maybe we have to implement something to warning the user before running the process. My grid was have too much point. Let's try with this. On grid. Okay. Let's choose. Yes. One time step. Grid spacing. Yes. Okay. Let's try. Maybe. Oh no, it's okay. Yes, I have it, but I don't see any point. It's failed again. Yes, I don't. Okay, believe me, it works.
Okay, no problem.
I don't know why it works now. I have to investigate because maybe it is a CRS issue. I don't know. Because this one is a particular because it is an American one. I don't know it very well. Okay. Other processing. We can do the same thing when we have. Oh yes, maybe it will be working here. Let's try it. If I do one, yes. Oh no, I have a serious issue with this one. I don't know why. Okay.
No problem. You're on the bleeding edge. We can expect these things to happen sometimes.
Yeah. Yeah, it is master. So if people want to try on the report issue, it will be a pleasure for me to fix the issue.
Great. So is there anything else that one should know about when using mesh on QGIS? I think you covered a lot of different functionalities that maybe people didn't even know that were there. So it's really been a nice tour. Are there any other things that you can do in mesh that that probably people are not aware of?
Simplification, maybe. Simplification, yes. That's why simplification. I'll restop master because I have issue with it. Yes, but when you have a very big mesh and QGIS is very long to respond, you can use a simplification. It's quite long to load because I have already made the simplification. So when loading, you have to load the mesh and the simplification too.
Is the simplification stored like a pyramid, like a secondary layer associated?
No, it's you just have to rebuild the simplification again. Each time we load the layer. So you have to load the layer and then make the simplification. I will illustrate what is simplification is. Normally we can see the yes. Okay, normal because simplification is activated. When you have a very thin mesh like this, I will display only the triangular mesh. Okay. If you zoom out, you can see the triangle are not the same. So the rendering is very faster. I don't know if you can see the different resolution.
Yes.
It's very convenient when you have a big mesh with a lot of vector, with a lot of arrow, for example. It speeds up the rendering a lot. And for 3D too. Let's try it with mesh. Okay. Why I don't see it, I don't know. Yes, I see it. Okay. Here I have the simplification that is activated, so I can. No, it's for dataset. Sorry. I will show you for the terrain. Here you have the level of detail slider. You can you see the mesh is simpler here. You have image is clear. Here you have a lot of triangles, and I set the number of triangles. Nothing. Yeah. Okay. So now the rendering is quite. I can do the same for the data set, but extreme cases. And now I can render, and I think there is less problems with rendering. Speed up the rendering. Nothing happened because I asked him too much maybe. Oh no, time is not looping. We can see. I don't know. We can see the arrow because maybe it don't work with simplification, simplified mesh. I don't know. So it speeds up the render. If I, you see here, it's quite too long to rendering, and if I reduce the level of detail, it's work.
Yeah, you can see a huge difference. Yeah.
Okay.
Okay, maybe it's a good time to wrap up this session, Vincent, unless you've got something more to show us.
No.
Your brain must be hurting by now trying to make show so many different things. It's really amazing all the work you and Lutra have been putting into the grid stuff, and I've been playing around trying to learn it a bit, and I think it's a whole new world to explore in QGIS. So it's really fantastic what you're doing.
But if people have questions, don't hesitate by text. It's really simpler for me to read on write.
Yes.
That book.
Yeah. All right. And what's the best way for people to contact you? Through the issue tracker on QGIS, or how do you like people to tell you about their mesh problems?
I don't know how people prefer. GitHub, maybe the usual pipeline. I don't know.
Cool. Well, we'll put a link to maybe to your GitHub profile in the notes at the bottom, yeah, and they can contact you via GitHub.
Yes.
And I guess Lutra and yourself are always available for contract work, right? If there's somebody who wants some new features.
Of course. Lutra Consulting can contact me. Yes. No.
Yeah, I'll put Lutra's website address in the YouTube description as well. All right. Thank you very, very, very much, Vincent. It's been a pleasure to learn from you, and I hope you can come and join us again in 6 months' time again to show us all the new things that happen.
Yes.
Okay. Thank you, everybody, and just a quick shout out to Jeff from who just woke up in Canada. Welcome to the channel. Goodbye to everybody else. Thank you for watching in the chat room. And there's some thank yous coming in from the chat room as well. So thanks, everybody, and we'll see you next time. You can thank the band in the background as well. We all enjoyed the music. Goodbye.
Et il mettait 3 frigos à moi, normalement. Et 2 ans.